here with everyone. So what we are going to do, we are going to learn about the BFS traversal. It will be the easy one, easy with compared to DFS. What BFS means? If I'm starting from zero, print all the labels first, then go to another level. Let's say from zero, it is going to print one, it is going to print two, four, then three, five, then six, seven. Let's say I'm starting from one. In the graph, if I'm starting from one, what it should print? It should print one first, then it is going to print two and zero because two and zero are at the same level. It does not mean the two is at the down position and zero is at the up position. It means they are only one. Let's say the cost of going from one to two is the same, and cost of going to one from one to zero is the same. It means there is cost is only one. Let's say from one node to, if the node is directly connected, if the cost of going from one node to this another node is the cost one, so it means from one to zero at the same cost you can go to from one to two as well. So first, if my starting node is one, so first it is going to print two, then it is going to print zero again. uh, in the again it is going to print another level, that is 3 4, then it is going to print another level 3 4, yes, then it is going to print another level, that is 5, then it is going to print another level, that is 6 and 7, because it will be, let's say it is 0 level 0, these two 0 and 2 will be the level 1, 3 and 4 will be the level 2, 5 will be the level 3, and 6 and 7 will be the level 4. Okay, is BFS traversal is clear, the concept of BFS traversal? Because if you have attended the session of BFS traversal of the tree, you are going to get it very easily. Means how we are going to do in the same manner we are going to use a queue. Okay, I hope it is clear with everyone. If you are having any doubt, you can ask me now. I'm waiting for your responses. But if you are not having any doubt, I can move to the coding part of BFS traversal. What do you want? I should be doing it using map or matrix or both again. Map. Okay, Shrey saying map. Let's do it with the map. May I know how vectors only map? Okay. How vectors? Okay, you're saying, may I know how vectors work? Vector is just an dynamic array. If you're saying, let's say we have discussed vector in the very initial session, what we are doing when we are doing the arrays. Vector is just, let's say, everyone just wait for 1 or 2 minutes. I'm going to explain the vector very quickly. If you still face any doubt in the vector, you can directly message me. So what a vector isn't just an STL, that an STL library that STL has provided us. Let's say I'm writing vector int of v. It means it is going to create an v, and it is going to assign some memory to it. Let's say it will be the dynamic memory, but let's say I'm going to add something to my vector. So for adding, I can directly write v of 0 because it is going to act like array in the same manner. If I'm writing v of 0 is equal to 6, I can write v of 0 is equal to 6, v of 1 is equal to 7, and v of 8 is equal to 9. Okay, so we don't need to means worry about the size. You can directly add as many elements as you want. Okay, I can write int here, I can write, let's say I can write string, character, anything, double, float, anything I want. Okay, and if I there are some functions as well. If you want to get the size of your vector, you can write v dot size. It will return an int, very int value that will be the size of this vector. And there are a lot of things. Either you can write v dot push back, push if you don't if you don't want to worry about that indexes part, you can just keep on doing v pushback, v pushback. It will directly keep on doing the things like keep on adding the elements at the back of, or it is continuous allocation, or it is like linked list. So again the question comes, so it is continuous in the STL. We can say yes, it is continuous, although STL has not provided us that complete data. Means anything means it is not possible for, means as STL says that it you can have any number of elements in this, but there are a lot of things that are going to be stored in our computers. So And if after some time it is let's say 7 or 8 blocks are saved here, it is going to come to here, it is going to come here. Then again, let's say 8 and 9 blocks is stored here, it is going to come from here to here. So we don't know actual what is the algorithm behind it, what they are using, but right now we can say that it is a continuous allocation. Yes, you can directly check whether v of what is the v of 3, v of 4, v of 5, means random access is there. So it is same like array, but you don't need to worry about the size. Okay. So again, let's come to our BFS traversal. In the BFS traversal, what we are discussing first, we are going to print our data of our graph in the level wise. Let's say from 0, if I'm starting from 0, it is going to print 0, 1, 2, 2, then 3 and 4, then 5, then 6 and 7. Okay. If I write v of 8, then 8 integer space is created, or it is like map. No, here it will be the memory will be allocated. It will not be like the map. That is the difference between map and vector. Okay, because map use the hash functions, and this thing would vector directly create those blocks in memory. Okay, so now let's create what we are going to do in case of BFS traversal. We are going to use a queue here, because let's say if I want to print 0, then what I'm going to do, I'm going to print all those nodes that are directly connected with this node. Then I'm going to come to its child. Let's say then I'm going to commit to its another level. Okay. So what I'm going to do, I'm going to create a queue. Let's say again, I'm going to create a blank queue here. Okay, Shrey, if you want to ask something, you can ask. You've raised your hand. Let's see what this queue is doing. I'm starting from let's say I'm starting my BFS traversal from 0. So first it is going to add 0 here, and I'm saying okay, so fine. So what I'm saying, until my queue is not empty, keep on doing these operations. What I'm telling you. So what the operations I'm telling him to do, let's say if 0 is here, I'm saying pop this 0 and print add all those nodes that is directly being connected to this node. So from 0, it is going to print 0 and it is going to pop, and from 0 the 1 is connected directly. And please keep a means please maintain a visited map as well, or visited array, so that I can know whether this, if it is not being visited at, so in that case only add these values into queue, or do not add. Let's say from 0, let's say right now our visited array is empty, or visited let's say visited map is empty. So what I'm going to do first in this, I'm going to add a 0 here. I'm going to add my first node in my queue, and I'm going to remove this queue, and I'm going to print 0, as well as after printing this element to 0, if I'm going to print this. So after printing this element, I'm going to update this as means visited of my 0 is true. So let's say 0 is being visited. Okay. Again, I'm going to come to 1. I'm going to say if 1 is let's say 1 is what I'm asking. If 1 is not visited at, what you need to do, add this node here, and what you need to do, just add my let's just update my visited node as well. Let's say if one has came into my queue, it means it is going to print definitely. Okay. So again, the one came, I'm going to remove one. The node of the visited of one has already updated, so we don't need to worry about that. Okay. So I'm saying print one, and print all those enter all those nodes that is directly being connected to this two, that is 2 is directly connected to 1. Push these node to queue. Okay. So what I'm doing, 1 has printed, so I'm going to print 1 again. It is going to come 2, so I'm going to pop 2 and going to print 2, and going to add, sorry, if I after printing, I'm going to update this as that it has already been updated. Okay. So again, when it comes to 2, it is if it has printed 2, what it is going to do, it is going to add all those nodes that is directly being connected to 2. So it is going to add 3 here, and it is checking whether these nodes are visited or not. So 3 and 4 are not visited, so it is going to add 3 and 4 here. Okay, so again it is our queue is not emptied, so it is going to print 3. So after printing 3, it is going to add that nodes that is directly being connected to this node. So there is nothing, no node that is directly being connected to 3. It is not going to add anything. So again, it is going to come to 4. So it is going to print 4. Okay, and it is going to add 5 here because 5 is the node that is directly connected to 4, and 5 is not visited. So I have printed my 3 and 4. So I should be updating my visited node. Okay, let's say 3 and 4 here. So again, I'm going to come to node 5. So I'm going to print 5, and I'm going to update my visited that 5 is also being printed. The 5 child is, let's say the 6 and 7 is directly connected to 5. So I'm going to add 6 and 7 here, and 6 and 7 is still not visited. So I can add my 6 and 7 into my queue. So I'm going to print 6 again, and I'm going to update 6 here, and I'm going to print 7, and I'm going to update 7 into my visited. Okay, is it fine? How we are taking the help of the queue for printing a BFS traversal. Okay, so let's create an BFS function. Let's see whether we are getting the output or not. Let's try to create a code for that. So what I'm writing here, cout BFS traversal. Okay, let's say printing BFS traversal. Let's change the line here because either it will be printed in the same line. Printing BFS traversal. And I'm going to call my BFS function here. I'm going to see pass that starting node because this will not be a recursive call. So I can create my what was that? Create my visited map in that function as well. Yeah, it is same like level order traversal, but visited queue is extra. Yes, as the same thing like level order traversal. Okay, so what I'm going to do, void BFS. Let's see, it is taking a variable that is intst, and what I'm going to write of queue of type, take a queue of type int and name it as queue, and queue dot first enter this value into queue, and we create another visited thing that is visited, that is an unordered map of type int comma bool. As we have already discussed, it will be the type int, and the type bool, the value will be type of bool. It means if it is being visited, it will have the value true. If it is not being visited, it will have the value false. Let's say name of this visited node is true. So what I'm saying, while my queue is not empty, queue is not empty, what you need to do, you just take a variable, let's say a temp variable that is a, and store what is there at the front of our queue. Let's say it is there at the front of our queue, that is queue dot front. Okay, and I'm saying queue dot pop, pop that value from my queue and check, and just print my first this value because it is a, and update my visited node for a as true. If it is being printed, make it as true. So what I'm going to do now, I'm going to do a for loop. I'm going to run a for loop here, and I'm again in that manner in which we have did in the DFS part. What I'm going to write here, intx of this, let's say of map st. So it is going to return. So map of st will have the data that is directly map of st will have the return a vector that are the values of that nodes that is directly connected to st. So x will have the values one by one. So what I'm going to check, x is being visited or not. If visited of x is not true, if it is not being visited, so what you need to do, you just keep on pushing those values in the queue. Okay, is it fine? Okay, it is visited. Sorry, it will not be the visit map of st, it will have the map of a, because a is that value that we have popped from the queue. So I'm looking for the value that is directly connected to that value a, not that st. Okay, is it fine, everyone? Okay, let me check it whether we are getting the correct output or not. So we are getting 0, 1, 2, 4, 3. That's fine. 5, 6, and 7. Yes, we are getting the correct output. Either it can be 3, 4, or 4, 3. That does not matter in the graph, especially. So let's say I'm changing my starting node here in the traversal function. Let's say instead of 0, I'm saying start from 1. So if I'm starting from 1, so it should print 0 and 2 first. 1, 0, and 2. Yes, 1, 0, 2. First it is printing 1 and it is going to print another level, that is 0, 2. Then it is going to print 4 and 3, then 5, then 6 and 7. Is it fine, everyone? How we are getting, why we are getting this output? If I'm writing, if I'm changing it to 2, what we are going to get? We are going to get the output as 2, 1, 3, 4, then 0, 5, then 6 and 7. Because in respect of 2, 0 and 5 are at the same level. Yes, it is. So what output we are getting? We are getting first 2, then 1, 3, and 0. Yes, 1, 3, and 0. Why we are getting 1, 3, and 0? I should be getting from 2, 1, 3, and 4. I should be getting the output as 1, 3, and 4. It is the right graph we have created. No, it was we have added. So okay, we have created a wrong graph here. That's why we are not getting the output. It was 1 to 4. Let's quickly check it. Why? The 1 was 4. Let's verify it from that input what we have given, because we have given 4 to 1, not 4 to 2. Okay, so if it is 2, it is going to 3 and 1 are at the same level. Then 2, 0 and 4 are at the same level, so it is going to print 2 first, then 1, 3, then 0, 4, then 5, 6, 7. Is it fine, everyone? The correct graph is this one, not that one. Okay, so we have corrected our graph, and according to this graph we are getting this graph traversal. Okay, because this is the graph that we have given the input. For this graph we have given the input. Yeah, it is same like okay. So is there anyone who is having any doubt till here? The BFS traversal and the DFS traversal. If anyone wants, I can do that matrix traversal, or you can try it by yourself. How you can do it? The BFS traversal for loop line number 39. Okay, I'll be explaining it again, Aryan, for you. So what Aryan asking? What is the line number 339? Let's say I'm starting from 0, Aryan. What will happen in that case? It is going to create an queue, and in the queue it is going to add the value 0. Okay, and it is going to create a visited map that is completely empty now, and it is saying while my queue is not empty, what you need to do, int a is equal to queue dot front. In my queue there is only one data, that is 0, and what I'm saying, that print pop that value. So 0 is being popped. I'm saying print that value. So 0 is going to be print. Let's say my starting node is 0. Let me change it first, then you'll get it easily. Then we'll be keep on getting the solutions as well. So Aryan, in that case, what we are getting, the 0 is going to be print, here. Okay, the 0 is being printed here, and I'm saying visited of a make it true. So visited of 0, it is making it as true. And I'm saying for auto x map of a, in a map of 0, map of 0 is, it means it is going to return this vector. Okay, because this is the key and this is the vector, so it is going to return this vector. And this vector we are having only one value, so what it is going to say, if that value is not being visited, so one is not being visited, so I'm going to push that value into my queue. So in my queue there is only one data now, that is 1. So again I'm going to call, again this while loop will continue and it will keep on doing the things like in that manner. Okay, for everyone, is it fine now? So I'm going to end today's session if it is fine for everyone. If you are facing any doubt, okay, do one thing. Uh, Make this BFS traversal for this matrix representation as well. See whether you are getting it, or whether you are able to create or not the BFS traversal. If you are able to do that BFS traversal without any help, it means you got the logic behind BFS and DFS traversal. Okay, then it will be the clear of it will be the revision for that tree as well. Okay, try to do it by 2